welcome to another video. It's that time of the year again. It's Advent of Code and we're gonna have so much fun. I'm gonna try to get all the way to 25, but we'll see how many days I will actually handle. And usually when we have this kind of intro, I have some sponsor shots here. But this year, the sponsors that were reaching out was mostly AI companies that didn't really meet the actual seal of approval for me. They weren't really having a product that they could go to market with yet. So this year, as the creator economy is a little bit strange, I much rather think that you should give some of your appreciation to an other creator. So I will put my donation link in the description, and I don't really care if you give me money. You can if you want, but I want you to pick out some creator that you watch regularly, that you really like what they do, and then give them a small donation saying, hey, I really appreciate what you do. So that is my call out for this year. Let's get into some Advent of Code. Day 8, Playground. Equipped with a new understanding of a teleporter maintenance, you confidently step into the upgraded teleporter pad. You rematerialize on an unfamiliar teleporter pad and find yourself in a vast underground space which contains a giant playground. Across the playground, a group of elves are working on setting up an ambitious Christmas decoration project. Junkbox. Through careful rigging, they have suspended a large number of small electrical junction boxes. Their plan is to connect the junction boxes with long strings of light. Most of the junction boxes don't provide electricity. However, when two junction boxes are connected by a string of lights, electricity can pass between those two junction boxes. The elves are trying to figure out which junction boxes to connect so that electricity can reach every junction box. They have a list of all the junction boxes positioned in a 3D space. Your puzzle input, for example. So this is our example here. Let's put that into an example file. This is a list that describes the position of 20 junction boxes, one per line. Each position is given by X, Y, Z coordinates. So the first junction box in the list is at X 162, Y 817, and Z 812. To save on string lights, the elves would like to focus on connecting pairs of junction boxes that are as close together as possible according to a straight line distance. In this example, the two junction boxes which are closest together are, and then we have a couple of those here. By connecting these junction boxes together, because electricity can flow between them, they become a part of the same circuit. After connecting them, this is the single circuit which contains two junction boxes, and the remaining 18 junction boxes remain in their own individual circuits. Now the two junction boxes which are closest together but aren't already connected, directly connected, are, after connecting them, since that is connected together with an under junction box, this is now a single circuit which contains 3 junction boxes and an additional 17 circuits which contains 1 box each. The next 2 junction boxes connect are, and after connecting them, there is a circuit remaining of 3 boxes with a circuit containing 2 junction boxes and 15 which contains 1 junction box each. And then we continue, and those are already on the same circuit, nothing. The next 2 junction boxes are blah and blah, because these 2 junction boxes already are on the same circuit, nothing happens. This process continues for a while, and the elves are connected that they don't have enough extension cables for all the circuits. They would like to know how big the circuit will be. After making the shortest connections, 11 circuits, one circuit with 5 junction boxes, one circuit with 4 junction boxes, and 2 circuits with 2 circuit boxes, and the 7 circuits in each containing and 7 circuits which each contain a single junction box. Multiplying together the sizes of the 3 largest circuits, 5, 4, and the one with 2 sizes, produces 40. Your list contains many junction boxes. Together, the 1,000 pairs of junction boxes, which are the closest together. The list contains many junction boxes. Connect together the 1,000 pairs of junction boxes which are closest together. Afterwards, what do you get if you multiply together the sizes of the 3 largest circuits? Next 2 junction boxes are, because these 2 junction boxes are already on the same circuit, nothing happens. This continues for a while, and they're concerned with the extension cables for all these circuits. They would like to know how big the circuits will be after making the 10 shortest connections. Then we have 11 circuits. Okay, so we are doing it for 10 times. That's an important distinction. Okay. So I guess we need to create a bunch of boxes. We need to create a connection between these boxes and so on in order to figure this one out. And we also need to have information on how far it is to each box in a list as well. Yeah. So I'm gonna work on this for a while, and when I've figured something out, I will come back and explain what solution I came up with. And we're back, and I finally got a result here with a lot of finagling back and forth. And let's see if this is the correct value. No, your answer is too high. And we are back, and now I have a smaller value. So let's see if that is the correct value. Yes, you get a gold star. I get a gold star. Everybody gets a gold star. So let's look at what we did here. This was a little bit complicated, something that I needed to think about a bit. So first we created a class. I called it JunkBox. And I started to work with these kind of XYZ coordinates, but I realized that making this function where you actually calculated the distance was not that fun. And there is a 3D class in Java, so you could use that instead. Maybe my algorithm would work, but sadly, when I did this square root, I got a bunch of not a number results, which is not really good. And I also had this circuit ID that I put on everything. So what I did in the beginning here was take out the coordinates, create a 3D pointer. I could set and get the actual circuit. I used this 3D class to get the actual distance between them. And I also have something to find it in lists and so on. So I had this equals. I'm not really sure that I have actually used these ever, but I added them just in case. So the actual code here was first the reader up here, and then the number of connections, because that differed between the test case and the actual real case. We needed 10 connections in the test case and 1,000 in the real case. And then I just created a bunch of junk boxes here. And then I wanted to create a bunch of pairs of them. So I had this double, which were the distance. So in this length map, we have junk boxes, an array of junk boxes, and it could be a list as well if the length are equal between a number of pairs. So I go through here, and the first array I go from 0 to box size, and the other one I go from the iterator plus 1 and to box size. So I will check every pair, and then I check the distance, and the distance I get back, I see if the length map has that distance. Otherwise I create a new array list, and I put this pair into that array. Next up, I will create a length array, and this is so I can find the shortest length, and I just add all the key sets here, so all the keys from the map, and then I will sort that. So now I have a sorted list of all the length, so I can actually figure out what circuits is closest and so on. So now I want to create circuits, so that's because I have this hash map here with circuits. We have the circuit's ID and then a list of junk boxes that are in that circuit. I have a circuit iterator where I start on 1. Could I start on 0 because I have -1 in the actual checker. And then I go through until connections, and I get the first pair here, and it could be multiple pair for the shortest length. And then I go through all these pairs, and if none of the pairs are in a none of the boxes in this pair are in a circuit, I will just add the circuit iterator number to those. I will create a new circuit in the array list, or a new circuit in the map, and then I will put both of these connections into that, and then iterate on the circuit counter. So the next time we come to this case, we will create another circuit. And if the first one is in a circuit and the second one is not, then we will just take the second one, set the circuit number of the first one, and then we will add that to the first one's circuit. And we will do the opposite if we have the other case where the second circuit is in a circuit, but not the second box is in a circuit, but not the first one. And then we have the case where both of them are in a circuit, and the circuit is not the same as the same circuit. So they are in different circuits, but they are both in a circuit. We will connect two circuits here. Then I will take the ID of the second box and get that circuit number. So we have the old circuit number. We will get all the junk boxes in that circuit. We will set the first circuit ID to that. We will add it to the first circuit, and then we will remove the second circuit, or the old circuit. So when we've done that, we had created circuits of a particular length. I will then create the circuit sizes, go through all of these and just get the values, and the size of all these array lists are the actual values. I will sort those and then pick out the 3 shortest and multiply those with each other, and I will get a number. So this was how we solved part 1. Let's go into part 2. The elves were right. They definitely don't have enough extension cables. You need to keep connecting junction boxes until they are all in one large circuit. Continuing the above example, the first connection, which causes all of the junction boxes to form a single circuit, is between the junction boxes at blah and blah. The elves need to know how far those junction boxes are from the wall so they can pick the right extension cable. Multiplying the x coordinates of those 2 junction boxes produces this value. Continue connecting the closest connecting pairs of the junction boxes until they are all in the same circuit. What do you get if you multiply together the x coordinates of the last 2 junction boxes you needed to connect? Okay, so when we actually end up in a case where we connect the last 2 junction boxes, we need to check the x coordinates of the last one. When everything goes into one circuit, we don't have any more boxes to connect, then we will check what the numbers are. Yes, I will look into this and get back to you. And we are back, and I got this large value here. Let's see if that is the correct one. Yes, you get a gold star. I get a gold star. Everybody gets a gold star. So what did we do in this one then? Well, in this one we had the same kind of calculations that we did before. We did the same thing up here with creating the boxes and everything. And then we did the length and we started creating circuits. And the circuit calculation is exactly the same. We are doing the creating of circles. We are adding either the left or the right side to the circuits. And we are also removing and adding the old circuit. The extra thing we're adding are this statement at the end here. So when we are doing each of these connections, we check, okay, are we at the place where we now only have one circuit? And in that case, we have, I could have done this much cleaner, of course, but this little thing here is taking the circuits, get all the values, and get the first value. So this is pretty much just, okay, we have one result, get the value of that result, and that is an array list. So we will check the size of that array list, and if that array list is all the boxes, we have one circuit to rule them all. And in that case, we now have added a get x value, and we will create a big int of the first box x value and multiply that with the second box x value, and we will get the result and print that out. So part 2 was actually simpler than I thought when you actually got to think about it. So this was day 8 of Advent of Code. I hope that you found this interesting. I hope that you learned something today. If you have any comments or suggestions, leave those in the comment section down below. I really want to see your solutions. If you like this video, give it a like, share it with your friends and colleagues. If you haven't subscribed yet, please do that. And I really want to see you in the next video.